Um, Two properties are important for lines. Perpendicular lines are lines, let's say L1, we will say is perpendicular, and we use this symbol to L2. Um, if the two lines intersect, if and only if, so we have an intersection, L1 intersect L2 into one point, okay, and and we have an angle of 90 degree, okay, the two lines form an angle of 90 degrees. Let's say L1A, L2, notation of the angle, okay, is 90 degree. Okay, so perpendicular line is illustrated by the x-axis and y-axis. They intersect in the origin, and we have x, o, y is 90 degree. Okay, and the intersection of the x-axis intersect y-axis is the only point, the origin. Okay, so this is a yes, an example, simple example. Another property, important property of lines is parallelism. Two lines, L1 is parallel to L2 if their intersection is empty. Okay, L1, so strictly parallel. There is also, yes, parallel means just, okay, and distinct, let's say, and distinct. So we want an intersection that is empty. And um, yes, that's all. Yes, that's all. It's enough to have this condition in the plane. Okay, this characterization. So okay. Let's illustrate which line. For example, I can imagine a vertical line like that to y. There it is. Position y 2, for example. So this is the equation y equal 2. This one y equals 0. These two lines are different because they are parallel. Um, because here, so they don't intersect, and yes, they don't have any common point. Any point here on the y equal 2 is at a distance of 2, which is strictly positive. So there is no common point with the two lines. Okay, so the line y equals 0 is parallel to y equal 2. Okay, yes, let's then now, how can I characterize, knowing the equation of a line, uh, the equations of two lines, if they are perpendicular or not? Here is a characterization. So if we have L1 as y equal m1 x plus b1, and L2 is y equal m2x plus b2. So then if they are in this situation, we can write them like that. Then we can say L1 is perpendicular to L2 if and only if you have the product of the slopes equal -1. And the two lines are parallel, okay, if and only if they have the same slope, okay. And so this is the case where our lines, that means um, they are not vertical. Okay, we have also a vertical line is always perpendicular. Um, okay, a vertical line called horizontal, and an horizontal line. Let's erase this. Okay, and an horizontal line are always perpendicular. A vertical line is perpendicular to an horizontal line. So these are important results, characterization for these two properties when we have equations given, equations of the lines. Okay, let's then do some practice on that. The first question, for example, So let's identify which one. So yes, so let's call them. We have L1, for example, it has equation y equal to x plus 1. L2 has equation y equal x minus 1. L3 has the equation y equal minus x plus 1. L4 has the equation y equal to x minus square root of 3. And then L4, L5, the equation x equal 1. L6, the equation y equal minus 2. L7, the equation x equal minus 1. And finally, L8. L8 has the equation y equals 0. So let's identify which of the lines are parallel or perpendicular to each other. Okay. So if I look at the first four questions, they are given in the form mx plus b. The one else is also L8. I can consider them with an m equals 0, with a slope equals 0. So let's see if we have, yes, if we have one of these properties. So here I see a 2 for the slope. Here I see 2 of the slope. So we have, yes, a parallel. Let's make a table for our answer. Okay, so which one are parallel? Okay, and which one are parallel lines, perpendicular lines? Okay, so I can say that L1 is parallel to L4. Mhm. What about L2, L3? If you multiply the two slopes, that gives me minus 1. So L2 is perpendicular to L4. What about x equal 1? If I do x equal 1, it's vertical. Sorry, here it was x, it's not y. It's x equal 2. Okay. So if I draw x equal to x1 and x equal minus 1, okay, so let's do it here. X equal 1, let's say here it is, and x equal minus 1. So that's approximately you have x minus 1. So I see that my two lines and x equal minus 1 are parallel. Okay, they are at a distance, at the same distance of the y-axis, which is 1 unit. So we can say that L5 is parallel to L7. What about the y, the lines y equal minus 2? Let's do that. Sorry. Okay, let's do it approximately. Here is y equal minus 2 and y equals 0. Y equals 0 is my x-axis. Okay, y equals 0. Do it like that. So this is y equals 0 and y equal minus 2. Okay, let's say minus 2. So the two lines also are at equal distance, so they are parallel. Yes, so L6 is parallel. Sorry, so L6, I put it here, L6 is parallel to L8. What else? What else? L2 and L3. Which one we can add? Is there other between L1 and this vertical now? Which one are perpendicular now? If I look to x equal 1 is perpendicular to y equal, so I will have L5, for example, perpendicular to L6. L5 is perpendicular to L8. Okay, again, yes, and it's yes, it's the property is commutative. Okay. Okay. So this is how we can deduce those two properties from the equations.